Yes. Okay. Time is 3:15. Time is 3:15. We'll start. Uh, Main topic. Now I think I told you optics, there are several subsections. First subsection is refraction through plane surface. That is finished. Last day we discussed all the points and we finished doing that chapter. Now we are starting a new chapter, that is refraction through prism. Optics number 2, refraction through prism. Next topic. Refraction through prism, that is number 2. Refraction through prism. Now I think you all have idea about the shape of a prism. But I will draw for your understanding. You also draw with me. The shape of the prism will be something like this. The prism. Start drawing with me. The shape of the prism. The shape of the prism. Am I correct? So if I ask you now, when you consider as prism, how many triangular surfaces are there? There are 2 triangular surfaces. There are 3 rectangular surfaces. Okay. Now when we learn about refraction through prism, now look this surface. Now look this surface, this rectangular surface. This blue colored rectangular surface. This blue color rectangular surface, I name as surface number 1. Right, this blue color rectangular surface. And this red color rectangular surface, I mark it as surface number 2. Now just think that a light ray is incident on one of the surfaces. A light ray incident on this blue color rectangular surface at a certain point. Okay. Now look here. Now I am taking a cross section. I am taking cross section of the prism. Look here. Stop being look at here. I am taking cross section, triangular cross section of the prism. If you consider this triangular section, light ray incident at this point at the surface 1. So then hereafter, I represent my prism as a triangle. But you should understand prism having 2 triangular sides and 3 rectangular sides. In prism, when we talk about refraction through prism, light rays incident on one rectangular surface. Light ray refracts from other rectangular surface. For an example, blue color surface, light ray incident, red color surface, light ray refracts. That is the idea. But hereafter, when we represent a prism, we only draw triangles. Triangles. Then, if I draw my incident ray, this is my surface 1, blue color surface. If I draw my incident ray like this, the refracted ray will be, the refracted ray passing through the surface will be something like this. So this side is blue color side. This side is red color side, number 2. Hands up who understand up to this, hands up. There is no issue, right? Can understand, right? Number 2. Write down. Write down. Write down. Under this chapter comma, under this chapter comma, the refraction through a transparent prism is studied. Under this chapter comma, the refraction through a transparent prism is studied. Why they are in transparent? If this prism is not made with glass, let's say if it made with a wood, then is it possible to undergo refraction? Can't, right? That's why transparent. Transparent prism is studied. Next point, write down. All the questions related to prism are explained. Next point, write down. All the questions related to prism are explained. Considering the cross-section of the prism, considering the cross-section of the prism, which is triangular in shape, which is triangular in shape, triangular in shape. I explained that point also. Now, case number 1. Considering the cross-section of the prism, on it. Considering the cross-section of the prism, which is triangular in shape, which is triangular in shape, which is triangular in shape. Done. Case 1. Write down case 1. Write down, when the refractive index of the prism is greater, when the refractive index of the prism is greater, when the refractive index of the prism is greater than the refractive index of the medium, than the refractive index of the medium, where the prism is kept, where the prism is kept, and when the light ray incident, and when the light ray incident on the first surface, on the first surface, inside the bracket capital AB, close the bracket. On the first surface, inside the bracket capital AB, AB, close the bracket. Emerging from the second surface, emerging from the second surface, inside the bracket AC, inside the bracket AC. Now again draw a large rectangle. Again draw a large triangle, and now we are explaining what would happen when there's a refraction through a prism. Now start drawing a large triangle. Don't draw small triangles, draw a large triangle. I'm also drawing large triangle. I'm also drawing large triangle. Draw a large triangle. Now this side, this blue color side is AB. If not, we can tell surface 1. AB, if not surface 1. Right? That red color rectangular surface is AC. If not surface number 2. Surface number 1. If not, this one is surface number 2. Now, light ray incident on the AB surface. Right? There's a light ray incident on AB surface. This is my incident ray. This is my incident ray. Okay. This is my incident ray. All right. So then how do I measure the incident angle? This is the incident point. Start drawing a normal at the incident point. If I start drawing a normal at the incident point, a normal, then what is this angle? This angle 90. How do we measure my incident angle? Incident angle measures from normal to the incident ray. Normal to the incident ray. So I put my incident angle as I1. I put my incident angle as I1. Now, case 1 they are telling. Case 1 they are saying what? Case 1 they are saying when the refractive index of the prism is greater than the refractive index of the medium. Refractive index of the prism is greater than the surrounding medium's refractive index. Look here. Look here, stop being look at here. They mentioned refractive index of the prism is greater than the refractive index of surrounding medium. So give the example for the materials I want to design the prism man. The surrounding medium material should be what? I'll ask from you. What is air? Which medium is surrounding medium? Which medium is your prism? If they mention refractive index of prism is greater than refractive index of surrounding medium, which medium? Give me example for a medium you consider as the prism medium and the medium you consider as the surrounding medium. So we can consider glass as the prism medium, air, if not water, as our surrounding medium. Because if you consider glass as your prism medium, no matter your surrounding medium is water or air, both of them have lower refractive index than the refractive index of glass. Okay. Generally, what we do in the questions, surrounding medium is air, prism is glass. Rarely we find prism glass and surrounding medium water. Some questions they tested prism medium is air and surrounding medium water also. They have tested like that also. We'll discuss that later. Mostly glass, air. Then this light ray refracts from air to the glass. Then what would happen for this light ray? Bends towards the normal. So it was following a path like this. Now this light ray refracts towards the normal. Am I correct? Refracts towards the normal. Then after refraction through this first surface, this light ray is propagating along the glass, again hit the common interface, glass and air. Again in the common interface, prism medium and surrounding medium. Again start drawing a normal at the incident point. If I start drawing a normal at the incident point, If I start drawing a normal at the incident point, normal at the incident point, so this angle is 90, then what would happen? Then what should happen for this ray? Now it's like light ray is passing from denser medium to rarer medium. Am I correct? Then it planned to move in this direction. It planned to move in this direction. But now light ray is refracting away from the normal. Am I correct? It planned to move in this direction, but now light ray refracts away from the normal. Away from the normal. Then the path of the light ray will be like this. Start drawing. Start drawing. Start drawing. Should draw a nice big triangle, huh? So just write down refractive index of surrounding medium N1. Refractive index of the prism is N2. Surrounding medium, same medium N1. So I consider my incident ray as PQ. This point R is my imaginary. R is my imaginary. Now, when you consider refraction at Q, if not refraction at first surface, the refracted angle, I mark it as R1. Refracted angle, I mark it as R1. If you consider refraction at point R, if not, if you consider refraction at second surface, this gonna be the incident angle. That I mark as R2. Normally we mark incident angle in I, but this incident angle I marked in R2. No issue. Refracted angle I marked as I2. Refracted angle I mark as I2. Okay. I'll ask a question from you. I'll ask a question from you. My question from you is, look here. What is this angle? I'm asking what is this angle? Tell me what is this angle? I am asking what is this angle? What is this angle? I1 minus R1. F1 weight, yeah, that is the way. I1 minus R. See, according to what vertical opposite? According to vertical opposite, look at the two lines. This line and this line, this angle is I1 means this entire angle must be I1. But this is R1. This angle must be I1 minus R1. If not, we call this angle as what name? So we can call this angle as, when you consider only the refraction at Q, this angle we can call as angle of deviation at surface 1. Angle of deviation at surface 1. So therefore, I will write it as simple D1. I1 minus R1 only. But I put it as simple D1. Simple D1. Simple D1. Now here, again I'll ask from Shimla. Now this angle R2. This angle I2. This angle R2. Entire this angle I2. I'm asking what is this angle? Think. Think properly. Any idea? Any idea? This angle is R2. Then tell me what is this angle? If this angle is R2, according to vertical opposite angles, what is this black color marked angle? That is also R2. Then what should be this red color angle? I2 minus R2. Do you understand? This entire angle is I2. This part is R2 means this part is I2 minus R2. I mark it as D2. That's it. Okay, quickly. Now we'll define the names. So quickly write down as soon as possible. Write down quickly. We'll define the names. PQ, capital P, capital Q. Incident ray, capital PQ, incident ray. QR, capital Q, capital R. QR, refracted ray. R is emergent ray. R is emergent ray. Simple I1. Simple I1, incident angle at first surface. Incident angle at first surface. Simple R1. Simple R1. Refracted angle at first surface. R2. Simple R2. Incident angle at second surface. Incident angle at second surface. Simple I2. Simple I2. I told you, right? Please be very focusful. I told you, right? So this is the incident angle, but I am taking it as R2. Normally, incident angle we mark in I. But here, incident angle I am marking in R2. I told you, right? R2 means incident angle at second surface. I2 means refracted angle at second surface. Refracted angle at second surface. What I told? I told I2 means refracted angle at second surface. Inside the bracket, write down emergent angle. Inside the bracket, write down emergent angle. Always mark this as your prism angle, capital E. Very important. Remember, this angle we are calling as prism angle, capital E. Capital A, prism angle. D1, simple D1. Simple D1. Angle of deviation at first surface. Simple D1. Angle of deviation at first surface. Simple D2. Simple D2. Angle of deviation at second surface. Angle of deviation at second surface. Simple D, I will explain, don't worry. Simple D, I will explain. Total internal deviation. Total deviation, whatever. N1, simple N1. Simple N1. Refractive index of the surrounding medium. Simple N2. Refractive index of prism. Capital AB means first surface. Capital AB means first surface. Capital AC means second surface. Capital AC means second surface. Okay. Now Now you should also be very careful, right? Now there are some critical points everywhere. Now simple D1 means we named as angle of deviation at first surface. Why? This PQ light ray is moving in this direction. This PQ light ray was moving in this direction. After the diffraction, now light ray moves in this direction. Initial direction in this direction. Now direction is in this direction. That deviated angle, angle of deviation at first surface. What is D2? This light ray was moving in this direction. After the diffraction, now it's moving in this direction. It was moving in this direction. Now it is moving in this direction. This change in angle D2. But we marked something simple D. That is the total deviation. Then how do we find the total deviation? You check the initial, if not incident ray. This is your incident ray. And you check your last ray. What's your last ray? RS is your last ray. PQ is your incident ray, first ray. R is your last ray. Look here. Look here. If I extend this PQ light ray, if I extend this PQ light ray, this is the initial direction. If I extend this final light ray RS, final light ray RS, this is the final direction. Am I correct? You will listen, okay? Initial direction, final direction. Then this angle is we are calling as the angle between initial direction and final direction. This is what we are calling as what? Angle of deviation, total angle of deviation. So mark this also. Up to now, everything is very clear. No issue? Have issue? No. Okay. Need some time to write? Then shall we apply Snell's equation for AB surface? Write down applying Snell equation for AB surface. Applying Snell equation for AB surface. Applying Snell equation for AB surface. We'll apply Snell equation. Just apply quickly. Apply Snell equation for AB surface. Apply it quickly. Apply it. Snell equation for AB surface. Apply it. N1 sin I equals into sin R. Am I correct? N1 sin I equals into sin R. Then refractive index of medium 1 is N1. Incident angle is I1. N1 sin I1 equals to second medium is N2. N2 refracted angle is sin R2. Sin R2. It's not an equation, no need to highlight. Just I'm saying. Then write down. Relationship between R1 and R2. Relationship between R1 and R2. Okay. Now here, this diagram look like bit messy, but try to understand. Okay. If I extend this normal line, and also if I extend this normal line, the intersection point I mark it as capital T. Intersection point I mark it as capital T. I will ask you, what can you say about AQT angle? What is the value of AQT angle? I am asking, what is the value of AQT angle? Not AQT. It's not AQT. It's AQT. What is the angle of AQT? 90 degrees. Why? Now she's saying AQT is 90 degree. Why? AQT means this is normal line. Normal line. Then this is 90. This is 90. AQT is 90. I'll ask from you, what can you say about your ART angle? ART angle? 90. AQT angle is 90. And you know ART angle is 90. Do you know what is quadrilateral? I can't remember what is quadrilateral. Can you remember what is quadrilateral? Can you tell me what is quadrilateral? What you learned regarding all levels? Quadrilateral. I can't remember actually. I don't know. Quadrilateral means geometry having 4 sides. Then the thing that she told, she's telling 4 parallel sides, something, what we call for that? Huh? Parallelogram. Parallelogram. Then right. Quadrilateral means a geometrical shape having 4 sides. Then don't you see, look here, this AQTR. All maths. It's like a maths class. AQTR look like a quadrilateral. Am I correct? Am I correct? This is point capital A. This angle 90. AQTR. This angle also 90. AQTR is a quadrilateral. I will ask you one question. All levels you learned, what is the addition of internal angles in a quadrilateral? 360 degrees. This is 90 plus something plus something must be equal to 360. This angle, QAR angle, I marked as capital E. QAR angle, I marked as capital E. Okay? Very carefully listen. Very carefully listen. This is very important. Okay? Up to now, everything is very clear, handsome. Up to now, everything is very handsome. I want you to tell QTR, not QTR. I want to know QTR angle equals to how much? I want you to tell QTR angle equals how much? QTR angles equals how much? QTR angle equals how much? This QTR angle. In terms of capital A, can't you tell what is this QTR angle? I want you to tell this QTR angle in terms of capital A. Do you know? You are saying? You are saying QTR is also A. You are saying 180 minus A. Shall we check that? Now we know that as QA RT is a quadrilateral. quadrilateral. What can we write down? We can tell that 90 plus 90 plus A plus 90 plus 90 plus A plus this angle how much? QTR must be equal to 360. Then what is your QTR angle? Your QTR angle must be equal to 360 minus 180 means 180. 180 minus capital A. Am I correct? I put this as equation 1. Equation 1. Very carefully listen. This angle is how much? 180 minus A. Okay. You can also tell, if you be very careful, now you told QTR in terms of A, 180 minus A. You can tell QTR angle in terms of R1, R2 as well. Hands up who can answer. You can tell QTR angle in terms of R1, R2 as well. Hands up who can answer. 1, 2. I will help you. I will draw the triangles and I will make it more visible. I am drawing this QRT triangle for your understanding. I am drawing this QRT triangle for your understanding. QRT. This angle is R1. This angle is R2. I want to know what is this QTR triangle. I want to know QTR triangle in terms of R1, R2. 180 minus bracket R1 plus R2. Then as you know, we can write down also. Also we can say, also QTR means 180 minus R1 plus R2 brackets. From equation 1 and 2, what can we do? From equation 1 and 2, look here, very important equation. You must learn by heart this. From equation 1 and 2, you can write down. You can write down what? 180 minus A must be equal to 180 minus R1 plus R2. Am I correct? Am I correct? Correct. Now this 180 cancel out. See? Then you are getting minus cancel out. Finally, you are getting capital A means R1 plus R2. This is important equation you must remember. You must learn by heart this equation, very important equation. This is important equation. Important equation. Hands up. Up to now, everything is very clear. Hands up. Quick, write down. Write down them. Write down them. Which one? Yeah. Why not? Why not? If you can remember, that's okay. Next week, if I ask if you can answer it, it's okay. After 1 year, if I ask from you also, it's okay. But if you fail to answer, it's not okay. I happens girl is coming every day. Now, normally when she come 1 day, she get absent 2 days, right? Will you write down? Write down quickly. Done. Finished. So now you have one important thing to understand here. Look here. Now, once you manufacture this prism, can we change this prism angle? Once this prism is manufactured, once prism is made, is it possible to change this prism angle? It's not possible. So always capital A must be constant. But depends on your incident ray, your R1, your I1 value, what's happening? Depends on your incident ray, your I1 value changes. When your I1 changes, who gonna be changed? R2, R1. R1 gonna be changed, okay? It should be R1. R1 should be changed. R1 should be changed. Okay? Right? Then what will happen? When incident angle changes, R1 changes, accordingly, who will change? A can't change. Just now we told that prism angle cannot be changed. Prism angle always constant. So then when R1 changes, for an example, let's say when R1 increases, when your incident angle I1 increases, when your incident angle I1 increases, definitely R1 increases. When your R1 increases, what would happen for the R2? R2 should decrease. R2 should decrease. If your R1 increases, remember, R2 should decrease. If you go the other way, now when I1 increases, we know R1 increases, then R2 should decrease. If you're going the other way, when I1 decreases, R1 decreases, R2 increases. That's the idea. Okay. If your I1 decreases, R1 decreases, R2 increases. That is the idea. That is the idea. Red color pen important write down. So whatever I write in the board, you also write down. Okay, it's okay. Red color pen important write down. Red color pen important write down. Prism angle is a constant. Therefore, algebraic sum of R1 plus R2. R1 plus R2 is a constant. That means when R1 changes, that means when R1 changes, comma, when R1 changes, comma, R2 also changes accordingly. R2 also changes accordingly. So you can write on this one also. Then apply Snell law for AC surface. Apply Snell law for AC surface. Apply Snell law for AC surface. I am all right. Not young like you, I'm all right. Hip pain is there, back pain is there. So when you apply Snell law for AC surface, Snell law, Snell equation. Snell equation for AC surface. Then what we can do? Then here what we can do? N1 sin I equals N2 sin I. That is Snell equation. Then for the second surface, incident angle is R2, refractive index of medium is N2. So N2 sine R2. N2 sine R2 must be equal to the refracted medium will be again N1, refracted angle I2, refracted index N1, refracted angle I2. N1 sine I2. Hands up, who wrote this one answer? N2 sine R2 equals N1 sine I2 answer. This is also not important, but in the question, you should be able to apply it if you want. Okay. Then subtopic, finding the total angle of deviation. Still we can't do any questions. Finding the total angle of deviation. Subtopic, finding the total angle of deviation. Finding the total angle of deviation. Write down. Write down Roman number 1, no simple layer, whatever. Angle of deviation. Angle of deviation. Angle of deviation at AB surface. Inside the bracket, the simple D1. Write down the equation for simple D1 in terms of I1 or whatever. Write down an equation for D1 in terms of something. What I told is angle of deviation at AB surface. Write down. D1 means, I told you before also. This is your D1. This angle is your D1. And D1 means what? I1 minus R1. Yes. So then we can write down D1 means I1 minus R1. Very good. So D1 means I1 minus R1. So keep it as okay. Okay. And also simple Roman number 2, simple BO, angle of deviation at AC surface. Angle of deviation at AC surface inside the bracket. D2. 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 Very carefully answer. Huh? Now D2 is here. This entire angle is I2. This is D2. This angle R2, I told you this angle also R2. What is D2? Is it I2 minus R2? Yes, I2 minus R2. Yes, I2 minus R2. I2 minus R2. Then total angle of deviation. Simple C, total angle of deviation. Simple C, total angle of deviation. Inside the bracket, simple D. Then understand, total angle of deviation means understand angle of deviation at first surface AB plus angle of deviation at second surface AC. Am I correct? So this deviation plus this deviation is the total deviation. So what you can do, simple D means, D1 means what? I1 minus R1. D2 means what? I2 minus R2. So very carefully listen. So then D means I1 plus I2. If I bring these two together, I1 plus I2 minus R1 plus R2. Up to now, everything is very clear answer. Very. So what I am doing, very carefully listen, I am moving R1 plus R2 to the left. Then I can write down R1 plus R2 plus D must be equal to I1 plus I2. I am asking from you, from Shimla, I am asking from you, R1 plus R2, can we replace by someone else? Rather than writing R1 plus R2, can I replace it with someone that we all love? We don't love anyone? No, there is some kind of someone, that someone. So R1 plus R1, rather than writing R1 plus R1, can we write it as someone else that you know? Maybe you don't like, that you know now. R1 plus R2 means we learned it as now what? When you look at the board, you can tell. R1 plus R2, we can write it as Zoom. R1 plus, don't you like A? You like A, right? Therefore, we can write R1 plus R2 means from this equation, that is the capital A. The next important equation is prism angle plus total angle of deviation equals to I1 plus I2. Very, very important equation. Very, very important equation. Summary, look here, summary. Summary. There are two important equations you want to remember. What is first one? A equals R1 plus R2. Second one, A plus simple D equals I1 plus I2. Now take your tutor, we can do questions. Now it is mentioned as question number 35. I will give some time also. Madam, take the tutor. Question number 35. Mm. 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 Start doing yes, 35, yes. 35 only. But see, all the time they don't give, look here. In a prism question, all the time they don't give incident angle, incident rays like this, like this, like this. They don't give like that. But see here, look here, they are telling something. They are telling for a certain incident angle. Look here, for a certain incident angle, they are telling this refracted angle is passing tangentially. Look here, for a certain incident angle here, this ray is moving tangentially. Then what is this I2 angle? 9 degrees. Then what should be R2? What should be R2? Last week we learned. If a light ray is moving from denser to rarer, when that laws can apply everywhere in optics. Whenever you see light rays moving from denser to rarer, if your refracted angle is 90, what is your incident angle? Critical angle, C. Now, if this light ray is moving along the interface, moving from denser to rarer, refracted ray along the interface, this angle 90. Then what is your R2 angle? R2 must be C. Then R2C means you know how to find R1. I am not telling anything. Capital A value is 60. So write down in that question, they haven't given capital A value is 60. You want to find this I1 value in the question. It takes some time. I will give time is exactly, it's a good question. Hands up, who can do the question answer? Yes, can do the question. Time is 4:12. I will start explaining at 4:20. Keep on doing. First of all, draw a sketch. To support you, I will do the ray diagram. To give a small support, I will do the ray diagram. If not me, if you finish online people also, if you finished, put a reply. Now put a reply. I think you will reply to that Nasmia Ali, that account only. If not, you can WhatsApp. You can WhatsApp until we finished. Okay. Now what they are telling, there is a prism. You want to find I1 value. You should have logbook and everything, right? You should have logbook and everything. Okay. Now I will help you. See, draw a prism like this. This is your prism. Okay. Now, see. Now look here. Look here. Stop doing. Look at here. I'm drawing. Look here. 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 This is your incident ray. Am I correct? Am I correct? What is this? What is that? Normal. Then what is this? Refracted ray. Okay. Then what is this? Normal. They are telling what? After refraction from the surface, what will happen for the light ray? Move tangentially. That means moving tangentially. Look here. Then see what is now. You want to find the question. You want to find your I1. In the question, you want to find your I1 only. In the question, you want to find this angle only. I'm helping you. Look here. You want to find this one, but you can't directly find this one. You have to find several others to find I1. Just think. Look here. Stop doing. Look at here. Look at me. Look at here. This median refractive index I put as N1. Refractive index of prism N2. Again, medium N1. If they don't specifically mention, N1 is AR. N1 is AR. If they don't mention specifically, surrounding medium is AR. You know that I told you when light ray moves from denser to rarer. When light ray moves from denser to rarer, if the refracted angle is 90, what is your corresponding incident angle? Critical angle. I told you critical angle. That means your I2 is 9. Look at here. Look at here. Now, when I explain, don't look at not. Most important thing is my explanation. That is the most important. Then, after explain, you refer the not. Okay. When your R2 is 90, sorry, when your I2 is 90, what is your R2? Critical angle C. Based on that, try to find this angle. Try to find this angle R1. If you found R1, look here. If you found R1, again you can apply Snell law for refraction at first surface. N1 sin into sin R. Then you can do it. This angle given as 60. I guided also. Do it quickly. I will give some time. Do it. I want all of you to do up to a certain level.
Don't waste the time. Quickly find online people. Any of this Pavitra finished doing? Afra finished? Hands up. 290s, 140 something. Pavitra, what is the, tell me, what is the critical angle for C? Afra, if you found critical angle for C, put a reply. No, you should reply, not, you should reply for, I think, yeah, Nasmia Ali only you had to reply. Don't reply for Suleiman Nawaz. If you are replying, reply for Nasmia Ali. Found the answers? Online people. Afra, no reply. No, she never replies. Even in the physical class also, she never replies. Who is correct? You are right. Oh, that both these two girls and boys correct. Why? Oh God. Put the value quickly. So I'm doing. I'm doing. You finished, right? Got the answer? Almost going to get the answer. I'm doing. Now, my target is finding I1 only. But the problem is, I can't directly find I1. First, I want to go from back to the front. First of all, I want to consider refraction at second surface. Then only I have to come to the refraction at first surface. So therefore, we learn this idea when light ray goes from denser to rarer. If your refracted angle is 90, this incident angle, C means what? Actually, C means according to how we define the angles, C means you are R2. Ni? C means you are R2. This 90 means what? 90 means you are I2. According to how we define the angles, C means R2, 90 means I2. So I consider I am applying Snell at second surface. Snell at second surface. Then I can apply N1 sin I equals into sin R. N1 sin I equals into sin R. Something related to that, ni. 41 degree, how much? 5 minutes, ni. She got something like that. We'll check. Then surrounding medium is air. Surrounding medium is air. Refractive index of glass is 1.52. So N1 is 1. N2 means 1.52. Given data. So I can write down. N1 means 1. Incident angle is sine C. That's what I want to find actually. I don't know C. I don't know C. N2 means how much? N2 means? My bad here. I made a mistake. Look here. Now I'm considering these two mediums. Incident ray, refracted ray. Then N1 means refractive index of glass actually. That means 1.52. This value is 1.52. 1.52 into sine C must be equal to refractive index of air 1 into sine 90. Sine 90 means units 1. So then we can write down sine C means what? Sine C means 1 over 1.52. If you carefully look at the C value, madam, when you divide 1 or 1.52, shall we take log and shall we simplify it? Quickly tell me. Log and simplify it. Tell me, madam. 1 means we know 1 means sans notation 0.0000. 0 ni? 1 means? 1 means how much? 10 means how much? Okay, 10 means 0.00. Tell me 1.52 log 0.152. 15 you also check, recheck, 0.6. Tell me, man, 0.6578. 6578. 6578, right? 15 to 6578. No. I am asking what I'm asking. I am asking 1.52. Look at the log table, you confirm it. Look at the log table and tell me 15.2 means how much? 15.2. 1790. 1790. 18.8. Hi. 1818. 1818. Okay. 0.1880. Want to subtract. Then here it's 2. Here 918. Here 981. 918. Going 1 here, going 1 bar 1. Bar 1 is bar 1, 8182. So tell me this anti-lock. Anti. Tell me the anti-lock. 81, 82 anti-lock. 65, 8. Is this correct? I will do the last one. I want 4 number only from you. 65, 658. 658 into bar 1 means the bar minus 1. That means 0.658. 0.658. Look here. Sin C means 0.6580. You got this? You got this? You didn't simplify using log? Should simplify after using log. Don't go with this method. Don't go with this method. It's not good. It's wrong practice, okay? It's not a error practice. Okay, now tell me, take the sign table and tell me. Then C means what? C means what? Take your sign table and tell me C means what? C equals how much? 41 degrees, 8 minutes. Is it correct? 41 degrees, 8 minutes. Right, okay. Now we'll take a break, not now. We'll take a break now, 4:35. We'll take the break at 5:15, 5:20. We'll take a break, okay? Now I found C1. Look here. Is that finished? We just found C, but actually I want to find I1. I am asking you, R1 equals how much? Look, how can I find R1? Look here. C means R2. We learned an important equation. A means we know that A means R1 plus R2. This is an important equation. A means R1 plus R2, important equation. Now your C means actually R2. R2 is C. I want to find R1. So what can I do? A means how much? Prism angle 60. Prism angle is 60. R1 means, that's what I want to find. R2 means C, that is 41, 8 minutes. Then if I subject R1, R1 equals how much? 60 minus 41 degree, 8 minutes. Then 52 minutes, 42, 18 degree, R1. If I know R1, now I can find what I want, I1. Again, you want to apply Snell. Apply Snell at surface 1. apply Snell at surface 1. N1 sin I equals into sin R. Right? N1 sin I equals N1 sin I equals into sin R. Okay, online people also actively participate. Okay, keep on working. N1 sin I equals into sin R. If I consider first surface, N1 means 1. N1 means 1. Sin I1. I want to find actually I1 only. N2 means 1.52. Sin R. Sin R means this R1. R1 value I found 18 degree 52 minutes. 18 degree 52 minutes. Now tell me. Now tell me, I want to find sin I. What is the sin 18 degree 52? Tell me. 0.3234. 0.3234. Correct. Correct. No, check it, man. 18 degree 52 sine table. Check it. Check it. Someone confirm then. Okay. Right. Now, madam, tell me the log values. You check it. Log values. Now, log table. Log values. Log table. Tell me the log value of. Tell me the log value of madam. 1.52 means 0.1.1818. 1818. 0.3234 log value bar 1. Tell me the phone number. 32, 34, how much? 5097. You confirm. I am adding. Multiplication means addition. Then 15, 19, 11, 9, 6, bar 1. Am I correct? Anti. 6915 anti. 0.4914. Eh? Huh? Tell me like that. 4914 into minus 1. Then 0.4914. Now sin I1 means we know. Sin I1 means we know. 0.4914. I1 means sin inverse 0.4914. What is the angle? Now again sin table angle. It's a headache. 29 degree. She is studying 29 degree. 29 degree. 26 minutes. Hands up, who got this? One. Or you got this? Is this correct? Right, online people also raise your hands if you understood. Online people raise your hands if you understood. Online people raise your hands if you understood. Afra listened and Afra raised the hand. Pavitra, are you there? Pavitra, are you there? Okay, a thumb shape understood. A thumb. Yeah, she put a thumb and she raised the hand. That question is done. I hope you guys understood this question, how to do this one. Next, start doing next one. Start doing next question. So then I help you everything. After doing 35, after doing 35, after doing 35, shall we try 37? Shall we? Now these are difficult questions. Just try 37. Just try 37. It's difficult, I think, bit. Then 37. Then try 38. 37, 38. Then try 37, 38. Just try 37, 38. But 37, what they are asking? 37, what they are asking? Okay. Now I will explain, then you can get an idea. But draw a nice diagram. Draw a nice diagram. So the next day we can start lenses. Then we can start optical instruments as well. Now this question, this is the graph. 30 what? 30? 37. 37. Now there is a mirror. Now you don't worry about mirrors. So when we do 1-2 questions, you understand what to do when there's a mirror. You get an idea. There's a mirror. This kind of mirror. Don't bother with this. Now you should see how this light ray incident on this prism ABC. How this light ray incident prism ABC. A, this point is B, this point is C. Now when you carefully look at the way it enters to the AC surface, perpendicular entering. This light ray is entering perpendicularly. This light ray is entering perpendicularly. This light ray is entering perpendicularly. Okay, they mention light ray enters, light ray incident at AC surface perpendicular way. Am I correct? Now remember, I told you this idea, but I am not sure whether you can remember or not. I am not sure. If the light ray perpendicular to a common interface, if a light ray is if light ray is entering, if light ray incident perpendicular to a common interface, are there any deviation in the path? There is no deviation in the path. Am I correct? If a light ray entering perpendicular to the common interface, there is no deviation. Light ray doesn't undergo refraction. Then light ray follows same initial path. Write a small point, red color pen. If light ray incident perpendicular to the common interface, if light ray incident perpendicular to the common interface, if light ray incident perpendicular to the common interface, comma, 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 it doesn't undergo refraction. If I mean, I wanted, it doesn't bend. Okay, it doesn't undergo refraction. No, it does not bend. It does not bend. It does not bend. It does not bend. Follows the initial path. It does not bend. Follows the initial path. Okay, then you understand. Look here. You understand. This light ray follows the initial path. Then incident at what surface? Incident at, look here. This light ray incident at AB surface. Now look here, now here, this is the normal drawn at this point. Normal drawn incident point.
Have they given any angle? This angle given as 30. Look here. This angle 30. Look here. Stop being, look at it. Look at it. Now stop being, look at it. This angle 30. Then this angle is how much? 60. This angle how much? 90. Then this angle how much? 30. Then this angle how much? 60. So do I want to write down this angle is 30? This angle is 60. This angle is 60. Okay. Have they given refractive index? Refractive index of glass refractive index 1.5. Now initially they are telling surrounding medium is air. Surrounding medium is air initially, okay? Surrounding medium air means refractive index is how much? 1. Refractive index of glass they mentioned as how much? 1.5. Refractive index of glass, understand, 1.5. Ng means 1.5. Now first of all tell me what is the critical angle. Now you should remember, if the refractive index of glass is 1.5, refractive index of air is 1, what is the critical angle for glass air interface? You can remember. Critical angle for glass air interface, if you want, you can do it and you can check, you can do the calculation. But I told you, learn by heart. What is the critical angle for glass air interface? You understand, right? (41°). Critical angle for glass air interface 41°, 48 minutes. Now tell me, look here, look here. Now this light ray. Now look here. I am interested with the refraction at this point. This is my incident ray. I want to understand whether there is refraction, normal refraction, no. There is critical refraction, no. Internal reflection, no. I want to check what's exactly happening. Critical angle is 41, 48°. I'm asking from you. Hands up, who says? Hands up, who can answer? This angle is 60. Critical angle for glass air is 41, 48. What is happening at that point? Refraction, no. Critical reflection, no. Critical refraction, no. Total internal reflection, no. What's happening there? Hands up, who can answer? Why? Why you are saying like that? Critical angle, exactly. Exactly. Why? This incident angle 60 is greater than critical angle. Right? If any incident angle greater than critical angle undergoes total internal reflection, then what should happen to this light ray? This light ray reflects, as usually reflects, comes back. See, it's not difficult. When you look at this diagram, look like difficult, but see the understanding way. Then what is this angle? 60. I am doing a normal here, so stop looking. Then what is this angle? Then what is this angle? 30. This is 60, is 30. Now this light ray incident in a mirror. Mirror means definitely reflection. Mirror means definitely reflection. Look here. Then this must be 30. 30. This must be 30. Then what is this angle? 60. See, in order to do the question also 60. Then I'm asking, what is this angle? 90. 90? 60, 30, 90. Then your light ray Do you think light ray refracts at this point? Why? Why? Because I told you, if this light ray is perpendicular to common interface, no refraction. See, what happened here? Light ray normal to common interface. No refraction. Here also say this angle 90. 90 means what? Light ray normal to common interface. No refraction. But what they asking the question then? What they asking? Calculate the corresponding. Already I have done for you people. Just copy down then. Already I have done everything for you. Then copy down then. Copy down then quickly. Copy down quickly. Okay. Yes. They are telling the next question is immersed in water, man. They are telling initially surrounding medium is air, and they are asking us to draw the diagram. Later they are telling if the surrounding medium is water, then again draw the diagram. That's what they are telling. But I want you to do, look here. Now nothing to do in first part. I have done everything. Look here. Look here. I have done everything for you, right? What you want to do is, again from the beginning, yeah. Now this prism is immersed in water. Now look here. Now this prism is immersed in air. Then I drew the ray diagram. I have done everything. So now you want to copy this and you want to write down. Again, you draw the prism. Again, draw the prism. Surrounding medium is water. Then decide what will happen and draw the ray path. Not they are different, huh?
Right, okay. Now see, now they are asking if surrounding medium is water. Surrounding medium is water, they are asking you to redraw the diagram again. Now if I redraw it, surrounding medium is water. If I redraw the diagram, look here, this is A, this is B, this point is C. Light ray perpendicular to the common interface does not undergo refraction. Incident at AB surface. So as we already found, incident angle is 60. This angle is 60. But you know that this is glass medium, surrounding medium is water. I told you what is the critical angle for glass water intermediates. What is the critical angle for glass water intermediate? What is the critical angle for glass water intermediate? 62 degree, 44 minutes. I told you, I asked you to learn by heart them. If you learn by heart them, you can tuck gala, you can get the answer 64 degree, 44 minutes. Now see, now what's happening? I'll ask from you now. Now, critical angle 62 degree something, your incident angle 60. What should happen at this point? Usual refraction. Usual refraction. Then density error. Bending away from the normal. Find this angle. Then finish question. Find this refracted angle, then finish the question. Hands up, who found this angle, answer? You can't find it. You want to find this angle because they are asking you to find all the angles. Your incident angle is 60, find the refracted angle. I can apply Snell. I can apply Snell. N1 sin I equals N2 sin R. Apply Snell. Apply Snell. So when you apply Snell, N1 sin I, N2 sin R. N1 means glass, first medium is glass. 1.5 sin 60, incident angle 60. N2 means 1.33, 1.33 something. Sin, I want for this angle R. Then sin 60 means how much? 1.5 root 3 over 2. Sin 60 means we know that, we can remember root 3 over 2. That means 1.732 over 2. If I move this one here, 1.33. Am I correct? Equal sin R. Equal sin R. Sin 60 means root 3 over 2. That means 1.732 over 2. 1.33. Now look here. Now I can do something like this. I can do 1.5 over 2 means 0.75. 0.75 into 1.732 over 1.33 sin R. Tell me the log values, madam. Bar 1, 75 how much log value? 75? 8750 51 1.732 0.1732. Find 1732. 1732. 2380 2385. Add them. 6 13 11 11 0. 1.33 log 12, tell me. 12 39. Subtract. Want to subtract this. If you subtract, you are getting something like this. I'll write here. If you subtract this, you are getting 7 9 8 9 bar 1. You subtract 16 30 9 11. Yes, it's correct. Anti. Tell me anti. 9897 NT. Why 9897 NT? Tell me NT. Ah, 9766 minus 1. That means 0.9766. So I'm writing sin R means 0.9766. So therefore R means, tell me the angle. 9766 angle, tell me. 9766 angle, tell me. 77 degree something. 77 degree 34. Done. Raise your hands. Whatever we learned so far. Time is 5:10. Whatever we learned so far, genuinely understood, hands up. Online people also hands up. Online people also raise your hands if you understood everything, hands up. Everything very clear. Okay. So now we'll take a small break and we'll come. We'll take a small break, wash your face, eat something, and come. What's the time now exactly? 5:58. I 5:6. I am giving 5:6, 5:26, 5:25. We are starting again from 5:25 until 7:25 something. Okay. Take a small break and come. But we can't go out. Right, okay. So we'll start. We'll start again. Mm, okay. Write down something like this. Deciding whether there would be a internal reflection. Deciding whether there would be an internal reflection from second surface for the light ray. From second surface for the light rays. So if I repeat it again, deciding whether there would be an internal reflection from second surface for the light rays entering from first surface. Entering from first surface. Okay. If I repeat it again, deciding whether there would be an internal reflection from second surface for the light rays entering from first surface. Entering from first surface. Okay. Now Roman number one. Roman number one. Roman number one. Yeah, it's case two. Case two. Your main thing is case two, Roman number one. Okay. Now again draw a prism. Again draw a prism. Roman number one, write down when your R2 is less than critical angle. When your R2 is less than critical angle. When your R2 is less than critical angle. Now you know what is R2. So let's draw the prism. If I draw the prism, so then draw the incident ray. Incident ray. Then normal. Then normal. Already you have this idea, but it's okay. Your refracted ray. Your refracted ray. Again normal. Now we know this angle is R2. Am I correct? This angle is R2. Look here. This angle is R2. Stop taking a look at here. If this R2 is less than critical angle, what should happen at here? It undergoes usual refraction. It undergoes usual refraction. Density rarer refraction. Do this. Do this quickly. Okay, write down. When the incident angle at AC surface, when the incident angle at AC surface Roman number one, still I'm explaining Roman number one. So after drawing this diagram, you want to write down. Write down when the incident angle at AC surface. Write down.
is lesser than the critical angle, comma, is lesser than the critical angle, comma, the light ray refracts, the light ray refracts at AC surface. The light ray refracts at AC surface. Roman number 2, when R2 equals C. Roman number 2, when R2 equals C. Then again draw this diagram. Quickly, don't waste the time. Now tell me, I'll ask from you. Basically, when R2 equals C, what would happen at this point? The light ray moves tangentially. That means light ray undergoes critical refraction. Critical refraction is angle is 90. Draw the diagram quickly. 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 Write down. When the incident angle at AC, when the incident angle at AC equals to critical angle. When incident angle at AC equals to critical angle, equals critical angle, comma, the light ray undergoes, the light ray undergoes critical refraction. Now, Roman number 3, when R3 greater than C. When R2 greater than C. When R2 greater than C. What I told? The light ray undergoes critical refraction. Light ray undergoes critical refraction. Roman number 3, when R2 greater than C. Again draw it. When R2 greater than C, again draw it. Now you know what's happening. When R2 greater than C, what's happening? Undergoes total internal reflection. In that case, Roman number 3, R2 greater than C. Then what's happening? This light ray undergoes total internal reflection. So then draw this angle also R2. Huh? Mark this angle also R2. Okay. Now I think you have an understanding of this. Now write down when the incident angle at AC is greater than critical angle. When the incident angle at AC is greater than critical angle, the light ray undergoes total internal reflection. The light ray undergoes total internal reflection. So mark these two angles R2, 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 R2. Okay. So now what you do actually is put your main topic. Yeah, I think you have this idea. You understand what I'm explaining. Main topic, write down. The variation of angle of deviation. The variation of angle of deviation with the incident angle, the variation of angle of deviation with the incident angle during refraction through the prism. During refraction through the prism. Now look here. Now again draw a diagram, a general diagram, a prism, a prism. Then incident ray, refracted ray, and emergent ray. Incident angle I1, R1, I2, R2. Draw them. Quickly. This angle is I1. This angle R1. This angle is R2. This angle is I2. This angle is capital A. So you know angle of deviation at here is D1. Angle of deviation at here is D2. Total angle of deviation simple D. Now very carefully understand. Now very carefully understand. Now the variation of total angle of deviation. The variation of total angle of deviation with the incident angle. This is important. Now, my y-axis, I consider total angle of deviation. Not D1, not D2. The entire angle of deviation value, I mark it as in my y-axis. Who is my x-axis? Incident angle. My x-axis, incident angle. So we will do this practical in the class also. Incident angle. Now look here. Now you are increasing. Very carefully understand. Now we learn two equations also. You can remember capital A prism angle means R1 plus R2. And also we know prism angle plus total angle of deviation. This one must be equal to I1 plus I2 as well. Okay. Now what will happen when your incident angle, this is your incident ray, when your incident angle gradually increases? I will ask you a question. Now you can increase your incident angle. Can you define a range that you can increase your incident angle? Can you define a range that you can increase your incident angle? Between 0 to 90, right? When your incident ray is normal, angle is 0. When your incident angle is tangential, angle is 90. That means incident angle can be increased from 0 to certain value 90. 90 only. Now you are increasing your incident angle, and now you are experimentally you are doing this practical, and every incident angle you are obtaining corresponding angle of deviation. That's a practical. So I will give some prisms. So you want to make that prism in different I values, and you have to obtain corresponding D value. So once you plot angle of deviation with the incident angle, we notice a graph like this. We notice initially when your angle of incidence, when this I1 increases, initially angle of deviation decreases. Then at a certain incident angle, your angle of deviation becomes minimum. Okay. Angle of deviation becomes minimum. When you further increase your incident angle, When you further increase your I1 value, again starts increasing the graph. Do you understand? No? Now it's an experimental result. Now you are changing I1 value from 0 to 90. Is 1 degree, 2 degree, 3 degree. Every incident angle value, you are obtaining corresponding D value. If you extend this line, and if you extend this line by using protractor, you can measure this angle, right? So when you draw the graph between D and I, you are getting a shape like this. What's happening? Initially, when you increase your incident angle I1, angle of deviation decreasing. At a certain incident angle of deviation is minimum. Minimum ni? When you further increase your I value, again angle of deviation start increasing. But see, intentionally I am not making this graph symmetric. It's not a symmetrical graph, okay? So it's like this. Something like this. Do this graph quickly. This graph quickly. Do it quickly. So mark this minimum angle of deviation as capital D. I will tell you. This minimum angle of deviation we are marking as capital D. We are marking as capital D. Draw this graph and tell me quickly. Now look here. Write down. Write down. When incident angle increases from 0, when incident angle increases from 0, comma, the angle of deviation decreases, the angle of deviation decreases, and obtains a minimum value, at a certain incident angle, obtains the minimum value at a certain incident angle. Full stop. When incident angle further increases, comma, the angle of deviation again starts increasing. Angle of deviation again starts increasing. Now this graph is very serious graph. Now, even though it looks like very simple graph, it's really a serious graph. If I ask you a question, right? Now, according to this graph, now see, now actually, who is this I? Incident angle, that means actually I1. So you are changing I1, you can't change I2, right? Because I2 means refracted something, emergent something, we can't change I2. But you are changing I1, you are increasing I1, you are drawing corresponding D value. You noticed, look here, you noticed for a certain angle of deviation, you obtain same angle of deviation at two different incident angles. See, you obtain, now see, now y-axis represents D values. you obtain certain angle of deviation, certain d value. Let's say angle of deviation is 45 degree. You obtain 45 degree for two different I1 values. You obtain 45 degree at two different I1 values. See, when your I1 is this value also, deviation is 45 degree. When your I1 value is this value also, your D, angle of deviation is 45 degree. I will tell you what are those I values which give same D. Very carefully understand. For your understanding, let's say angle of deviation is 45 degree. Angle of deviation is 45 degree. When your I1 is 30, for an example, when your I1 is 30, angle of deviation is 45. When your I1 is 30, this is something 40, this is 50. I say I2 is 55 for an example. When your I1 is 30, I2 is 55, D is 45. Okay. Now remember, I told you same angle of deviation obtained at two different I1 values. Am I correct? Same angle of deviation is obtained at two different I1 values. One angle, if you say, then tell me if I ask you, what is the incident angle which gives 45 degree angle of deviation? If I ask you, what is the incident angle which gives 45 degree angle of deviation? According to this example, the values I have taken, what is the incident angle which gives 45 degree angle of deviation? I1, what is that value? For example, 30 degrees. 30 degrees. But we know there is another angle also which gives same 45 degree angle of deviation. That angle is the I2. Right? Remember, when you keep on increasing your I1, now when you are I1 30, I2 is 55. Okay? Now you are increasing I2. When this I1 value again equal to I2, when your I1 is again 55, then also you are getting same angle of deviation. Hands up who understand? If you take this as your I1, this is always your I2. Genuinely hands up. If you understand, only hands up. Okay, I will tell when your I1 is 35, when your I2 is 45, your angle of deviation is 40. Okay. 40 degree angle of deviation you obtain for what incident angle? 40 degree angle of deviation you obtain for what incident angle? What is that I1 value? 35. Isn't it possible to obtain same 40 degree angle of deviation for another angle? Isn't it possible to obtain same angle of deviation 40 degree for another incident angle? What is that incident angle? 45. Summary is very simple. You obtain same angle of deviation for two different incident angles. Those two incident angles are I1 and corresponding I2. Do you understand? But this is not valid. This is not valid at one point. What is that point? What is the point? You get same angle of deviation for two different incident angles. That is the point. That point not valid at one point. At the minimum deviation, are there minimum deviation can you obtain at two different incident angles? Minimum deviation you can only obtain at one incident angle only. You understand? Hands up who understand I'm explaining. Red color pen write down important. Red color important write down. So mark down this I1, I2. Mark down this I1, I2. Simple D, capital D mark down. Write down. Except the minimum deviation case, except the minimum deviation case, there are there are two possible incident angles for a certain angle of deviation. For a certain angle of deviation. For a certain angle of deviation. So we discussed question number 37 as well. I will give 6 minutes. Start doing question number 38. Start doing 38. And sometimes I don't discuss and I might discuss something else. Start doing 38. Start doing 38. 38. If they mention coated or something, I think from that coated surface, it undergoes reflection. If they mention a certain surface coated, that light ray undergoes reflection. Okay. So let a small point. The light ray undergoes reflection. Write down. The light ray undergoes reflection from coated surfaces. The light rays undergo reflection from coated surfaces. I will give 5 minutes. Find the answer. Find the answer. Now what's happening? Light ray falling perpendicularly on the face AB. Falling perpendicular. But so don't suddenly draw like this. Now I would say draw somewhere here. Draw some kind of middle or bit upper in the middle. Falling perpendicularly. No, no. It should fall somehow. That light ray falling on AB should hit the AC. Okay. So you want to think in that way. No, correct. Why? So light ray falling on AB should hit AC. Is it hitting AC, right? Your one is hitting BC. So you try to make this light ray somewhere here, then it's hitting AC. Quickly, we don't have time. Then they are telling incident perpendicular to the face BC. Incident perpendicular to the face BC. Now first light ray perpendicular to AB does not undergo refraction at AB. Light ray perpendicular to AB does not undergo refraction at AB. Then it hits AC. AC. It hits AC. Now do the normal. You are drawing horizontal, right? But you have to draw like this, me. Normal. Draw the normal. But better you can take this light ray. This is fine. Or it's sitting here. If it hits here also, now difficult to draw this remaining part. So therefore, better if you can bring this light ray somewhere here. Okay, that's better. Then what will happen? Now that light ray, I will give some time. That light ray should incident BC perpendicularly. Now, that's you are drawing, madam. Light ray incident perpendicular to AB. This light ray perpendicular to AB. That's wrong. Now that light ray perpendicular to BC. Show, first of all, keep your ruler perpendicular to BC. Keep your ruler perpendicular to BC. Then go that side. Yes. Like that only. Oh, no. Now this light ray only reflect this light. Now this is a quartered surface. AC is quartered. Then this light ray only reflect. After reflected, it should hit the BC perpendicularly. After reflecting, that light ray should hit the BC perpendicularly. Yes, but but see now your diagram, see it 90, no need. So you should nicely draw 90. Better you can make like this. Wait, madam, go there. Am I correct? Now this light ray incident at this point reflects me. This light ray should reflect. Sometimes we might draw a reflected ray. How will you draw reflected ray? How will you draw? Just roughly draw it. Something like that only. But they are telling this ray is hitting BC perpendicularly. Then is this reflected ray is perpendicular to BC? No. Then how you draw perpendicular reflected ray to BC? No, you know. I'm going to explain now. Time is up. Yes. Continue. That is the idea. So I'm doing question number 38 also. I am doing question number 38 also. Start doing that. Start doing that. Start doing that. What they are asking the question? They are asking what? Find BAC angle. That means you want to find the prism angle. You want to find the prism angle. So okay, I will also try to do this. We'll put a small effort and we'll try to do this. Now I am drawing a prism. This question I am drawing a prism. So we'll try to do this question and we'll go to next section. Equal, yes.
So I am drawing a prism. We'll give a small effort to find the answer. Now this is the prism, right? This is the prism. Then if I draw my incident ray, look here. They mentioned incident ray is normal to AB. This is my AB. This point is C. Incident ray normal to AB. So I can now, the problem is depends on the point where you start drawing the incident ray. Sometimes you might fall in trouble. That's the problem. So I thought of drawing my incident ray like this, perpendicular to AB. Perpendicular to AB. It is perpendicular. If they tell perpendicular, draw a exact perpendicular line. Perpendicular to AB. Then what happens? Does not undergo refraction. See, then it's a problem. Perpendicular to AB. If it incident perpendicular to AB, perpendicular to AB. Perpendicular to AB does not undergo refraction. Am I correct? Incident at this point. But AC is coated. That means, is it possible to have a refraction at AC? It's not possible. But what's happening always? Reflection. So this light ray will reflect. This light ray will reflect. Carefully listen. This light ray will reflect. So how we draw reflected ray? We draw reflected ray like this only. So we might draw like this. But they are telling, I will draw my reflected ray like this. But they are telling this reflected light ray incident on BC perpendicularly. Then is this light ray perpendicular to BC? This light ray is not perpendicular to BC. Then I should draw my reflected light ray perpendicular to BC. Then what will happen? After this light ray incident at BC, after this light ray incident at BC, what happened? Tell me. After this light ray incident BC, what will happen? Go vertical only. Doesn't undergo refraction because we know light ray perpendicular to common interface does not undergo refraction. So what they are asking us to find the prism angle. We want to find capital A only. We want to find capital A. Let's give a small try to find capital A. We'll put a small try. This angle capital A. So, but we know then this angle is how much? Look here, stop doing, I'm doing. Look here, I'm doing. I'm the one who's doing. I'm the one who's doing. You are the one who's listening. Can't write down. If this angle capital A, this angle how much? 90. This angle 90 minus A. Then this angle 90 minus A. As you told, 90 minus A. Then this angle, tell me, A. Am I correct? It's 90. It's 90. 90 minus this angle is A. Then this angle, reflection. A. Understand, right? A. This angle, 90 minus A. This angle is A. Then we almost got the answer. If this angle is A, now that is what? Isosceles triangle. Isosceles triangle, if this angle is A, what is this angle? A. A means what is A value? What is the value of A? All the time he is asking questions from me. I think sir doesn't like. Great. Very easy. What is my white 60? A 60. See, small triangular magic is there. Quickly write down that and we'll start next section. That is the thing. If you properly draw the diagram, then easy. Okay. Okay. Done, right? Done, right? Okay, now put your main topic. Now put your main topic. Minimum deviation case. Now we are learning about, see, now I told you, now for different incident angles, angle of deviation varies accordingly. At a certain incident angle, we noted angle of deviation is minimum. Now we are talking more about this minimum angle of deviation. We are talking more about this minimum angle of deviation. Write down subtopic minimum deviation case. Subtopic minimum deviation case. Write down minimum deviation angle is obtained. Okay, red color pen. Red color pen. Minimum deviation angle is obtained. Minimum deviation angle is obtained when incident angle is equal to emergent angle. When incident angle is equal to emergent angle. When incident angle equals to emergent angle. When light ray refracts. When light ray refracts through the prism. Through the prism. Okay. Now I have to draw it again the diagram. Now, okay. I am explaining that idea using the same diagram, but carefully listen. But carefully listen. Now they are telling, very carefully understand, they are telling, okay, minimum deviation is obtained when incident angle equals to emergent angle. Highlight minimum deviation, incident angle equal emergent. Highlight minimum deviation, incident angle equal emergent angle. Okay. I'm going to ask you something. Think now wisely. Now you can remember for general prism, incident ray, refracted ray, emergent ray. Incident angle I1 at first surface, refracted angle R1 at first surface, incident angle R2 at first second surface, refracted angle I2 at second surface. Okay. Angle of deviation at first surface D1, angle of deviation at second surface D2. Prism angle A. What are the two equations we learned? A equals R1 plus R2. Other one? Other one? A plus D equals I1 plus I2. Now they are telling we obtain minimum deviation angle when your incident angle equals emergent angle. What is the notation that we use to represent incident angle? I1. What is the notation we use to represent emergent angle? I2. That means they are telling what actually? We get minimum angle of deviation when our I1 equals I2. Then I am asking a question from you. Now think, when your I1 equals I2, what can you say about R1 and R2? When your I1 equals I2, what can you say about R1 and R2? Hands up who says they should be equal answer. When you are I1, I2 equal, raise your hands. How many of you say they should be equal answer? No, it's not necessary answer. Raise. They should be equal. They should be equal. If you are, see here air and glass and air. No difference, right? If incident angle I1, refract angle R1. If I1 and I2 same means R1, R2 must be same. I1, I2 same. Okay, carefully listen. At the minimum deviation, understand. At minimum deviation, MD. At MD, you understand I1 equals I2. That means simple I. R1 equals R2. That means simple R. I will ask you then, can you, in terms of, now we know the equation. Capital A equals what? I1 plus, capital A means R1 plus R2. Capital A means R1 plus R2. Now tell me capital A for minimum deviation scenario. Now capital A general equation for capital A is R1 plus R2. For the minimum deviation case, can you modify that equation? Capital A equals 2R. We'll draw a diagram. I thought take a small rest. It seems we can't take rest. This girl's nose is going like this. Okay. So I am also shocking, not with, she didn't understand her nose. The alphabet I explained properly. And where is my marker here? Sometimes, I keep my markers in my hand and I search everywhere. Where is my marker? That is there. Okay, look here. Then, very carefully listen. Huh? Okay, you also start doing this prism. Start doing the prism. Start drawing the prism. Quickly drawing the prism. Draw the prism quickly. Draw it. A, B, C. Incident ray. Normal. And refract, sorry, emergent ray. A, I1, R1. R2, I2. Okay. Quickly. Now, in the diagram, draw this ray as incident and draw this ray as emergent also. This ray incident, this ray emergent. This ray incident, this ray emergent. Okay, look here. At the minimum deviation, carefully listen now. Remember,
At the minimum deviation, what's happening? I told you incident angle must be equal to emergent angle. That means I1 must be equal to I2. So we'll take I1 must be equal to I2, that has I. Okay. This is I. Then this I1 is also I, that means 30 means I2 value also I, that means 30, 30, 30. Then remember, if I1, I2 equal, definitely R1, R2 must be equal. So then, therefore you can write down, therefore, R1 must be equal to R2. That means simple R. That means simple R. That means simple R. See, then R1 also simple R, R2 also simple R. Okay, R1 also simple R, R2 also simple R. So then, so what is the equation we learn to find the angle of deviation at AB surface? Angle of deviation at AB surface, D1. Tell me someone. That means I1 minus R1. D1 means I1 minus R1. That means now I1 means I, R1 means R, right? So D1 means I minus R. Am I correct? Also, angle of deviation at BC surface. Angle of deviation at BC surface. Angle of deviation at BC surface. Then angle of deviation. Now, see, angle of deviation at BC surface. Tell me someone D2. D2 means what? We learn D2 as what? I2 minus R2. Now I2 we know that is I, R2 means that is R. So now what can we say about D1, D2? When you look at D1, D2 value, what can you say about D1, D2 value? They are equal. So therefore you can write down D1 equals D2. Okay. D1 equals D2. D1 equals D2. So I1 equals I2, R1 equals R2, D1 equals D2. Then I will ask you common sense. Common sense. Look here. Stop and look at here. Now, according to the conclusion, look here. According to the conclusion, look here. If I1 equals I2, R1 equals R2, the D1 equals D2, is it okay? Just look at the path of the light ray. If I1 equals I2, R1 equals R2, D1 equals D2, is it okay to go this light ray a path like this? Why you are saying no? Why you are saying? This girl is saying that it's not okay for this light ray to go a path like this. I'm asking why. Why you are saying like that? Because it is equal, and then why? Then explain. Then how it should go? You are saying this light ray goes straightly. Okay, last one, this girl. Rishada, tell me, is it okay for this light ray to go a path like this? They're saying okay. What about our fishery? This path, look at the path. Is it okay for this light ray? I1, I2 equal, R1, R2 equal, D1 equal D2. Is it okay to do okay for this light ray to go a path like this? They why? What you are telling is at the minimum deviation, this light ray diagram must be symmetric. Symmetric. Red color pen, write down, not red color pen, write down. Write down at the minimum angle of deviation, comma, at the minimum angle of deviation, comma. First of all, write what I'm saying. At the minimum angle of deviation, comma, number one. Red pen, number one. Incident angle equals emergent angle. Incident angle equals emergent angle. Refracted angle, number two. Refracted angle at first surface. Refracted angle at surface equal incident angle at second surface. Incident angle at second surface. That means inside the bracket R1 equals R2. Third point, angle of deviation at first surface equals angle of deviation at second surface. Angle of deviation at first surface equals angle of deviation at second surface. Super red color pen, last point. Refraction is symmetric from both sides. Refraction is symmetric from both sides. Refraction is symmetric from both sides of angle bisector of prism angle. Of angle bisector of prism angle. So what I told is refraction. What I told is refraction is symmetric from both sides of angle bisector of prism angle. What I'm telling is, see, if this diagram belongs to minimum deviation, if this diagram belongs to minimum deviation, I am telling something like this. If this is your prism, what I am telling is, your ray diagram should be symmetric about the angle bisector of prism angle. What is your prism angle? This is your prism angle. You know what is angle bisector? You know what is angle bisector? The line which divides angle equally. So this is your angle bisector. Then they are telling, if this ray diagram belongs to minimum deviation scenario, refraction, light ray must be symmetrical around this angle bisector. Angle bisector means AB, yeah? A for angle, B for bisector. You write it nicely. You don't write AB. Okay, then how would be your light ray diagram? Your light ray diagram will be very symmetric like this, symmetrical diagram. Incident, as you told, refracted ray will be horizontal. Emergent ray also same as this path. You understand? You understand? So, look here. Symmetrical ray diagram, symmetrical ray diagram. Okay, you understand, you can understand. Now, for this minimum deviation, we'll derive those equations. Shall I derive those equations for minimum deviation? Up to now, hands up, everything is very clear. Hands up to now, everything is very clear, hands up. Online people also hands up to now, everything is very clear. If you understand everything, hands up. Everything is very clear. Okay. So what you do now, a topic write down, topic. We'll draw that diagram later, topic write down. Relationship between prism angle, comma, minimum angle of deviation and minimum angle of deviation and refractive index of prism. Refractive index of prism. Now look here. Now I am deriving. You have to look at what I am doing. Look at here. Now I am deriving. You have to listen. Then you can write and we can do questions. Then story finished. Okay, then lenses. Okay, look here. Look here. Now, what is the equation we learned which gives relationship between I1, I2, A and D? I'll ask from A plus. I'll ask from you. I1, I2, A and D equation is what? A plus D equals I1 plus I2. Right? General equation, we know that. General equation is A plus D must be equal to I1 plus I2. So we know that at the minimum deviation, remember, A plus the simple D becomes capital D. The symbol for minimum deviation is capital D. A plus D equals I1 becomes I plus I2 becomes I. So then what is the now equation? A plus D equals what? 2I. For minimum deviation, remember, A plus D equals 2I. So this equation you must learn by heart. But I subject I for a reason. You learn by this equation A plus D equals 2I. If it is general scenario, A plus D equals I1 plus I2. If it is minimum deviation, A plus D equals 2I. When I subject I, what is my I value? A plus D over 2 equation 1. Am I correct? And also we know that we learned what relationship between A, R1, R2. A equals R1 plus R2. At minimum deviation, remember, R1 is R, R2 is R. Remember, A equals to R. This is also an important equation. In case in a question they mention minimum deviation, A equals to R. Minimum deviation, A plus D equals 2Y. Okay, exam they ask many questions from this. For a reason, I substitute R. R means what? A over 2 equation 2. Okay, right? Shall I apply Snell law for AB surface? Shall I apply Snell law for AB surface? At AB, looking at AB surface, I am applying Snell law. When I apply Snell law, N1 sin I equals, look here, N2, don't write, N2 sin R. What is N1? N1 means this medium, I say N1. Sin I means what? Sin I means? Sin I1 means sin I. Sin I N2 sin R. Then you can write down what? You can write down sin I to sin R ratio. That means if I subject N2 over N1 means sin I over sin R. Up to now everything is very clear. Now what I am doing from equation 1 and 2, what I am doing? From equation 1 and 2, instead of I and R, I am putting these two. Then I can write down N2 over N1 means sin I means what? A plus D over 2. Look here. A plus D over 2. R means what? So R means what? A by 2. Got it? This is an important equation. If they tell surrounding medium is air, your N1 is 1. If surrounding medium air, N1 means 1. Then you can write down N2, refractive index of prism, over 1. Over 1 not writing. Therefore, N2 means sine A plus D over 2 over sine A over 2 highlight. Everything is very clear? Then that's it. Then I am sitting 41, 42, 43, 44, 45. 41, start doing 41, 42, 43, 44, 45. I'm sitting for some minutes. You can do this question. Start doing 41, 42, 43, 44, 45, and also draw this diagram. Symmetrical diagram also draw it. Huh? I am okay. So I am giving 50 minutes something. Okay. So you can do these questions also. $6:35. Hands up. Who's the time and so quickly? Okay, we'll go with the time and so quickly. Hands up. Seriously? Then okay. Then we can do until 8 o'clock. Why?
After finished drawing this diagram, I want you guys to do try 41, 42, 43, 44, 45. Okay, try them. Okay, now time is 7 o'clock. Try them as soon as possible. Okay, do it by yourself. 7 o'clock, 6:55. Today time is so good. Start doing those questions. I will start discussing around 7:5. I will start explaining within 5 minutes. You finish first one? Our Rusha, the support give a small help for our Shimla. Give a small help. Shimla get the idea from her and do it by yourself phone. Get the idea? She's correct. Then okay. No, I'll start explaining. I'll explain. Now, I'll start explaining. Prism part is finished almost. 41, 42, 40, 40, 45. If I start explaining 41, if I start explaining 41, okay. Now tell me what is 41? Now I have time. Now I'm releasing 24 minutes. I have enough time. Look here. Tell me the idea. 41, read the question. 41. What they asking? Tell me. Louder. Refractive index. Glass how much? Given data. What they are saying, read the question. Angle of capital A is 60. Okay. Capital D is 39. Then find the refractive index. That means simple lane. I want to find simple lane. Then we derived an equation involving N, A, and D. N equals what? N equals sine A plus D over 2 over sine A over 2. Okay. N means sine. What is prism angle? 60. D means 39 over 2 over sine. A means how much? A means 60 over 2. Then N means how much? Sine 99 over 2 means how much? 49 sine 99 over 2 means how much? 49. 49 degrees 30 minutes over sine 30. What is value? Sine 49 30 means how much? 0.7604 over sine 30 means 0.5. When you simplify this, you are getting your final answer as 1.52. Next question, tell me 42. 42, tell me 42. refractive index of glass. Prism. Glass is how much? 1.666. Okay. Capital A is 60. All right. Have to find D. Have to find D. Again, same equation, right? Same equation this time. 1.66 must be equal to, I'm using same equation. Okay. N equals sine A plus D over 2 over sine A over 2. Am I correct? Now 1.66 must be equal to sine A is 60. 60 plus, I want to find D only, 60 plus D over 2 over sine A means 60, 60 over 2. Then 1.66 must be equal to sine 60 plus D over 2 over sine 30. This sine 30, I will move to here. Then how much? Now this, okay, sine 30. 1.66 into sine 30 sine. Am I correct? Sine 30 means how much? Half. Half means 1.6 is over 2. 0.83 must be equal to sine 60 plus D over 2. Hands up to now, who wrote until here? Thereafter don't know how to do. Thereafter most of you don't. Okay, we'll see. 0.83 I will tell you. You did sine 60 plus D over 2. Find the sine value. Now 0.83 means what sine angle? 0.83 means what sine angle? 0.83 means what sine angle? Find. You also find 0.83 means what sine angle? Eight. No. 56 degree. 56. We know 0.83 means sine how much? Sine 56 degree 6 minutes must be equal to sine. Am I correct? 0.83 means sine this angle. Sine 60 plus D over 2. What happens? Sine cancel out. Then you can write down 56, 6, 60 plus D. Look here, over 2. Now only you can move this 2. Am I correct? 56, 6 into 2 equals how much? What is this value? 112. 12 minutes, 60 plus D. D equals 50. How much? 112 minus 60 means how much? 52, 12. Got it? Okay, do remaining 2 questions quickly. Remaining 3 questions and show me and leave. And the last one should, as usual, clean my bag. This time it's difficult for you also. There are 2 boxes.